Hi, everyone. In today's lesson, we're going to talk more about integration rules. But before we can do that, I just need to recall the difference between a definite and an indefinite integral. So if I have an indefinite integration, that just means there's no lower and upper limit. And we use the rule that we've been talking about in class. We add 1 to the power and divide by that power. So I can go ahead and write that. Add 1 to the power and divide by that power. So we'll say this is 3x to the third over 3. We added 1, divided by that power. The integral here, add 1 to the power, divide by that power. And here for the 1, technically it's the same thing as writing 1x to the 0. So when you add 1 to the power, you're adding a 1 over 1. And that's why the antiderivative of 1 is just x. So we can simplify this and make this x to the third minus x squared plus x, and we always need to remember that plus c at the end if it's indefinite integration. So that would be my antiderivative. Now, the difference here, definite integration, all that means is now I have a lower and an upper limit. So I have to use that fundamental theorem of calculus that says take the f of a or f of b and subtract f of a. If my interval is my a is on the bottom, lower value, b is on the top, my upper value. So this capital F is just the antiderivative, which is this. So you're going to take your antiderivative just like we did here. So we have our x to the third minus x squared plus x, but this time we don't need a plus c because we're plugging in our lower limit of 0 and our upper limit of 1. So f of b is when I plug 1 in, so 1 to the third minus 1 squared plus 1. And then I need to subtract when I plug in 0. So 0 cubed minus 0 squared plus 0. So we're doing this whole thing minus this whole thing. So 1 minus 1 is 0, plus 1 is 1. And obviously, when I plug 0 into anything, it's going to be 0. So 1 minus 0 gives me 1. That would be my answer for my definite integral. So that's the difference. If there are no limits, you put a plus c. If there are limits, you have to use that fundamental theorem of calculus where you're plugging in f of b minus f of a. Okay, other types of algebraic manipulation that would be involved are concepts called splitting up a fraction or combining the expressions. So we can't, in the form that these two are in, we can't just add 1 to the power and divide by the power because it looks like it's in a weird form. So if we split up the fraction, it'll actually make taking the integral a little bit easier. So we're going to divide each of these three pieces by x. I'm just going to draw it out and write it. So we have 3x squared divided by x plus x over x minus 2 over x dx. So when I divide them, the first term, I just get 3x. Second term, I get 1. And this term, I kind of have to leave as 2 over x. I can't really divide them. So let's take the integral of each piece separately. So now I can add 1 to the power and divide by that power. This one, I know I can just make 1x. Now the issue is this one. How do I take the derivative of 2 over x? Well, some of you might be thinking, well, I can take this as a power of 1 and bring it upstairs. So that would be 2x to the negative 1. So if we did that and we added 1 to the power and divided by that power, the problem in lies is that when you do negative 1 plus 1, you actually get 0. And then when you divide by that number, you get 0. So you can't divide by 0, right? That's undefined. So there must be another way that we can find this derivative or antiderivative rather. So what I'm going to say is we're going to leave that for now. We're going to learn it in the next slide, and we're going to come back to this one. But for now, learn that we needed to split up the fraction, and we'll come back to this piece. Okay, sometimes you might need to distribute first. In the case like the second example here, we can distribute into here and into here. First thing I would do before distributing, though, is maybe rewrite this as x to the 1/2 and then plus x squared. So when I distribute, now it works where I can add the powers, right? When I have like bases, I add the powers. So I can make this 3x to the 3 halves, right? 1 plus 1 half is 3 halves. And then I can keep going. 3x to now x to the first times x squared. We add the powers again, and that's a 3. So now from this, I can take my integral. So now I can add 1 to the power and divide by that power. So when I add 1 here, I'm really adding 2 halves, which you can see is 5 halves. But instead of dividing by 5 halves, I'm simply going to multiply by the reciprocal. Makes my life easier. And then here, same thing, add 1 to the power, divide by that power. Don't forget plus c at the end. So my final answer, if I multiply these two fractions out, we get 6 over 5, x to the 5 halves, plus 3/4, x to the 4th, plus c. Now, if you wanted to, you could change this back to a radical form. If you did that, it would just be the square root of x to the 5th, and then you'd have your 6/5 in front. So that's just another way that you could have written that form. That's just good to know if it's a multiple choice question. Okay, let's jump to the back here. So if I have 2 over x, the answer is just going to be minus 2 ln of the absolute value of x, and then plus c. And then that's my final answer there. So now these are all of the integration rules that you will need, and we're just going to apply a couple of example problems. So the first one, the integral of 1 minus 5 over x. So we're going to take it separate. The derivative of antiderivative of 1 we know is x. And this is kind of like what I did in the previous slide. If we brought the x up, it's 5x to the negative 1. But the problem is that when you added 1 to the power and divided by that power, it's 0 over 0. So that's not going to work for me. So what I need to recall is actually something from a previous lesson. We know that the derivative of ln is 1 over x. So if I have 5 over x, the antiderivative is just 5 ln of x. So that is what we're actually going to write here. So the answer is 5 ln of x. And again, don't forget your plus c. So the reason why we have absolute value bars is because the ln can never be negative, right? It only can be positive. So that's why we leave those there. So let's just go back real fast. The rule of thumb is if you're adding 1 to the power and dividing by that power and you're getting 0, it's going to be an ln problem. Okay, what happens now if I want to take the integral of 7 to the x power? It's not e, so it's going to be this one. So we just have to follow the rule. The rule tells me it's a to the x, so it's going to be the same as in here, over ln of the base. So this answer is just 7 to the x over ln of 7, and then plus c. Okay, example number 3, I want to take the integral of 3 secant squared x dx. Now you could take this 3, pull it out on the outside, so it's 3 times the integral of secant squared x dx. Bells and whistles should be going off. We know that the derivative of tangent is secant squared, so the antiderivative of secant squared is just tangent. So tangent of x, don't forget the plus c, and we can bring down the 3 in front. Technically, you're supposed to be multiplying the 3 by everything in here, but 3 times tangent is just 3 tan, and 3 times any constant is still a constant. So I'm not going to write that step. I'm kind of just going to leave it like this. Okay, example number 4, integral of e to the x, and then this. This is kind of just putting a couple things together. Antiderivative of e to the x is just e to the x, so we'll make this e to the x. Here we can add 1 to the power, divide by that power, and don't forget a plus c. Okay, example number 5, we have 1 over 1 minus x squared. So bells and whistles should be going off here for 5. That is our inverse trig stuff. So we know the derivative of inverse sine is 1 over the square root of 1 minus x squared. So this one's nice and simple. This answer is just sine negative 1, or arc sine of x. And again, that plus c. Last here, number 6, is the same thing. We know that if I see an absolute value, it's likely going to be one of these inverse ones. So the antiderivative of 1 over this is secant. So this answer is inverse secant. Oh, I noticed that these need negative ones, so if they're not on your paper, please make sure you're adding those negative ones. Okay, last but not least are questions like 7 and 8. I'd actually like to see if you could try questions 7 and 8 by yourself with what you learned last year. If you can't, that's okay, but I still want you to give them an effort. So I want you to try questions 7 and 8 for homework, and then we'll start class actually going over those tomorrow. All right, have a good night.